See it. Probably hopefully it's starting. Ryan, do you get the sequence from 45? What is the original?
No, I don't.
Why do you guys never write
I
it
also
down?
don't have my book with me today.
Now you get it written down?
Yeah.
What is it?
1/2, 3/4, 9/8, and 27/16.
9/8, 27/16. Okay, now obviously that one is in the back of the book. You can figure it out from there. But as you take a look at it, this one is probably easier to treat the numerator separate from the denominator. So it goes 1, 3, 9, 27. All are powers of 3. But you got to be careful here, because if you do it like this and the denominator's powers of 2, you're close, but this right here wouldn't work, because if n is 1, it would give you 3. That would be a 3/2, 9/4. So what do you have to do to that power in the numerator? Make it n-1. Okay, because anything to the 0 power is going to be 1. So don't forget about that. So that's going to be 3 to the n-1 over 2 to the n. Did anybody come up with anything different? Every now and then you can come up with no more than one kind of equation that works. So, all right, that last one, 73, which some of you just conveniently forgot, which is all right. We'll hit it now. What is it? That is, what is the problem here? Is it n factorial over n plus 1 factorial? Okay. All right, how do you write out n factorial? Cole DeLuca, how do I write that out?
You would do n times n-1 times n-2. Keeps going down until you get to 3, 2.
So we get to 3 times 2 times 1. So we're multiplying those all together. Agree. All right, how about, Madison Lissy, how about n plus 1 factorial? How do I write that out? What do we start with?
N plus 1.
Got to start with n plus 1. What do you think comes next? N, because you subtract 1 from whatever you have here, which would give you n. Then what?
N-1.
N minus 2, all the way down. 3 times 2 times 1. All right, now what cancels? Or what's left? Basically everything cancels except for what in the denominator? The n plus 1. Okay, so everything's gone. Boom, boom. And we are left with 1 over n plus 1. Okay, for that one. All right, any other questions on the homework? Okay. All right, let's finish up those notes from yesterday, and before we get to the that next set, we have those ones at the very at the back. No. Here was the answer to 44. You could have written it all as one term. Basically, it's just going, 3, 6, 9, but it's alternating signs for that one. You cannot have that. You cannot have that in the denominator. Okay. All right. Now, let me see something. There we go. Adam Lippy, you know this terminology? Have you seen this before?
The E looking.
Yeah, the E looking thing.
Like the sum of all the numbers.
Good, the sum of all the numbers. You remember where you've seen it before?
Physics.
Physics. All right, so physics. It means the sum. Okay, this is a, what letter is that? You know what Greek letter that is? Sigma, capital sigma. Okay, so it means the sum of a sub I, and this tells you where to start. It doesn't have to start at 1. A lot of times it does. It doesn't have to. And this just tells you where it ends. So we plug in 1 and you go up by, since it's a sequence, you have to have whole numbers. So it goes up 1, 2, 3, all the way till you get to n. Okay, for that. So this first one here, it says find each sum. Basically, you plug in 1, then you plug in 2, you plug in 3, 4, and 5, and then you add them together. So for I equals 1, okay, basically it's just -2 times 1 or -2 plus I equals 2. That's -2 times 2, -4. This thing is not. Okay. And now just plug in I equals 3, plug in I equals 4, plug in I equals 5. So I'm just going to put those up here. I equals 3, I equals 4, I equals 5. And so when I do that, -2 times 3 is -6. -2 times 4 is -8. And -2 times 5 is -10. And then add those all up. And what is that? -30? So it equals -30. Okay. So the sum of -2i from I equals 1 to 5 would be -30. And I know on your papers is a little bit different in terms of notation because I couldn't get it to print out where the 1 was down below and the 5, I had to do it to the side. I'm not sure why. But it means the same thing. All right, let's take a look at that second one. -I squared plus 8, starting from 1 to 7. Just plug in 1, plug in 2, plug in 3, and then you're going to add them up. So for I equals 1,
Mr. Todd, on our paper, it says I equals 3.
it does?
Yeah.
All right, so I mixed it up on you. All right, let's start at 3. Let's see, I wonder if I can switch this one. They didn't tell me that in the last class. They don't care. Sorry, we couldn't update the equation. Let's see. Sum I equals 3 to 7, right? And parenthesis negative I squared plus 8. Oh, don't want that extra in there. Oh, that's big. Ooh. All right, so there we go. So we don't want I equals 3. Or we don't want I equals 1. And I think I did that to show that it doesn't always have to start at 1. So I equals 3. So that is going to be, oh, that's very awkward. -3 squares. Watch, you don't square the negative. So what's that first one going to equal? When we plug in 3, it's going to equal, Josh?
-1.
-1. Good, because it's going to be a -9 plus 8. So it's going to equal -1. Okay, plus I equals 4. And that's going to give me -16 plus 8. -8. I equals 5. Which gives me -25 plus 8, which is -17. I equals 6. Which gives me, what is that, -28? And I equals 7, which gives me negative, what is that, 41? All right, add those all up. 7, 9, 11, 13. Huh. Okay. Luke, what do we get? Oh, you're just gonna wait for everybody else to do your work. Give me a second. got, Luke?
Negative 95.
Negative 95. Ah, that's all. All right, negative 95. For that. All right, and then that last one there on the bottom. All right, a lot of times it's I, every now and then it's K. So K equals 0 to 3. Tells you to start at 0, tells you to end at 3. All right, you got negative 1 to the K power, K factorial. Is you got to do both of those parts for each K. So for K equals 0, you got negative 1 to the 0 power times 0 factorial. Well, negative 1 to the 0 power, anything to the 0 power is 1. What is 0 factorial equal? Defined yesterday. 1. Okay, that is 1. So 1 times 1 is 1. So K equals 1. Then I get negative 1 to the first power times 1 factorial. Well, 1 factorial, that is also going to be 1. So what do I get? I get plus negative 1. All right, go ahead and plug in 2, plug in 3, see what you get. Grace, what'd you end up with?
Oh, I'm not done yet.
Not done yet.
No.
Okay.
I'm sorry. No, I'm not even done
All right, plug in 2. Okay, make sure that's in parentheses.
That's right.
This one?
The negative 1. So that'll be from a positive.
yet.
Okay. There we go.
Yeah.
Okay. Cooper, what do you got? Negative 4? Negative 4, is that right? Negative or positive? Negative?
Negative.
Negative, okay. Negative 4, that sounds right. K equals 2 plus negative 1 quantity squared times 2 factorial, which is 1 times 2, which gives me plus 2. So this negative 1, that's going to make it alternate signs. K equals 3, negative 1 to the third times 3 factorial. 3 factorial is 6. Negative 6 plus negative 6. So in the end, it is negative 4. All right, so that is summation. Summation notation. When you see that big symbol there, it looks like an E. Means you take everything, you add it together, starting with like whatever 1 and ending with 5 or whatever that I equals to start with. All right, so that ends section 11.1. Let's go into section 11.2 on that second set there. All right, arithmetic sequences. And then I don't know if we're going to get to the second part. We might have to save that for tomorrow. Find the sum of the first n terms on it. All right, where's those guys? So let's see what we're looking at. All right, these are all arithmetic sequences. Okay. In 3, 7, 11, 15, 19, and 23. Anything that goes up by the equal amount or anything that goes down by an equal amount. So the second one goes down by 3. What about the third one? What does it increase by each time? It does increase by the same value. Aaron?
By 1.5.
1.5. There we go. By 1.5. Yep. Negative 5, that's negative 3.5, negative 2, negative 1/2, 1, 5 halves. Okay. it's an arithmetic sequence if there's a number D, okay, such that each term in the sequence except the first is obtained from the preceding term by adding D to it. This is your common difference. All right, D is equal to A sub n plus 1 minus A sub n. All you do is take any term and subtract the previous one from it. And that should give you what a D is. Now, if I go back up to those three sequences for the first one, D is 4. 23 minus 19 is 4. 19 minus 15 is 4. 15 minus 11 is 4. D is negative 3. 13 minus 16. 16 minus 19. 19 minus 22. And D is positive 1.5 for that third one. Okay, so that's what we talk about here for sequences. A common difference. Common difference. Okay. All right, the nth term of an arithmetic sequence. Nth term. A sub n. And this gets used a ton. So make sure you get that down in that blank there on the right-hand side. A sub n is equal to the first term plus n minus 1 times the common difference. Okay. All right, let's take a look. Oh, well, these next. Take a look at these next three. See if there's a identify the common differences in arithmetic. If it's not arithmetic, just put not arithmetic. All right, so take a look at those three. All right, Tyler, what's D for the first one?
0.8.
0.8, 0.8. Okay, good. For the second one, is that arithmetic? Okay, does that go up or down? Cold DeLuca, is it arithmetic?
No.
Nope, not arithmetic. Good. And Emily, how about the third one? Is it arithmetic?
Yes.
What's D?
-5.
-5. Good. D is a -5. If it's going down, decreasing, D has to be a negative. Okay, so that's just identifying them. All right, from yesterday, you should be able to come up with, this is similar to what we did yesterday. All right, so take a look at this one. See if you can come up with the A sub n for -3, 1, 5, 9, and 13. Okay. Because we talked about these yesterday. If it goes up by a common amount. All right, Kayla, do you know what A sub n is?
Not yet.
Not yet, like the positive thinking. Not yet. This has got to be like when you plug in n equals 1. Instead of you got -2. You plug in 1. Got it yet?
Yes.
What do you got?
4n minus 7.
4n minus 7. We talked about if it increases by a constant amount, there's a 4n in there. You just need to plug, when I plug in 1, I got to get back -3, so I got to subtract 7 to get that to work. 4 times 2 is 8, 8 minus 7 is 1. That would be your expression for the nth term. Now, that works. We can also use that formula up above to get that. Let me show you how you can do that. A sub n equals the first term plus n minus 1 times d. I can use that and I'll still get the same thing. Well, here's what you do. You plug in the first term. which is -3, plus we're going to keep the variable n, and I'm going to use d equals 4 because I know the common difference, and that goes on the outside here. And I know you've been conditioned to distribute like from the left-hand side, but you can also distribute from the right-hand side. Okay, so that 4 is okay over there. I'm going to distribute it in here, and then I'm just going to simplify. So I get a sub n equals -3 plus 4n. Whoops, hold on. One more. A sub n equals -3 plus 4n minus 4. So now a sub n equals 4n minus 7. All right, do I have to do it this way if I know how to do it that way? No, I don't care. Just give me 4n minus 7. Sometimes you like a little, but that formula is going to come up in other ways as well. All right, for the second one here, I'm going to use that formula. Go ahead and copy that down. Mackenzie, what's my D value?
4.5.
Say that again.
-4.5.
I don't think it's 4.5. I think it's close. One too far down. -3.5?
Yeah.
-3.5. So D is -3.5. And now I got a sub n equals a sub 1 plus n minus 1 times d. All right, I'm just going to substitute in and simplify. My first term is a 9 plus n minus 1 times -3.5. I'm going to keep that in parentheses so it doesn't look like I'm subtracting and I just make a careless mistake. Distribute the -3.5. Oops. And that gives me 9 minus 3.5n plus 3.5. A sub n equals -3.5n plus 12.5. There we go. Plus 12.5. Hey, plug in n equals 1. Make sure you get back to the first term. Okay, plug in n equals 2. Make sure you get back to the second term. Make sure it works. Make sure it makes sense. Okay. But you can, if you don't understand, all right, it's going down -3.5, and you can figure out the other way, that's absolutely fine. All right, now, but you got to watch on this last one. We're only going to do this one here today. We'll get the rest of it tomorrow, just because I know that we didn't get as far in the first class. All right, take a look at this. I want to see if you can figure out what D is. 75th term is 15. The 90th term is 45. You are told it's arithmetic, so you know it has to either increase or decrease by a constant amount. Okay, because you're told it's arithmetic. We need to figure out what that constant amount is. Okay. All right. Constant amount. How much is D? What's the D value? Tony, you know what it is?
Would it be 2?
It is 2. It is 2. Now, if you're not seeing how yet, There's a little bit of a trick to it. It's not just guessing. We're not just guessing. And let me do something first. Let me just write down, you don't need to write this down, but let me just put down 4, 7, just make a sequence. 13, 16, 19, 22, 25. We know this is 3, right? The D value. We know this one's 3. Let's just take a look at it. So if I take a look at the second term to the 1, 2, 3, 4, 5, 6, 7th term. Okay, so the second term is 7. The 7th term is 22. Well, to go from there to there, how much does it increase? It goes from 7 to 22, which is an increase of how much? 15? How many terms did it take to get there? It took, from 7 to 2, it took a total of 5 terms. So basically, if you take 22 minus 7, that tells you the difference between the two terms, and you to take the difference of the number of terms, this will give us our D value. 15 divided by 5 is 3. So it took me 5 terms to go from 7 to 22. Okay? Well, how do I use that with this case? The 75th term is, what is the 75th term? 15? 15. The 90th term is 45. So it went from 45 to 15. I'm going to subtract the latter minus the former. And then how many terms did it take to get there? 90 minus 75. It took me 15 terms to move 30 spots. So 30 divided by 15 is 2. That is my D value. Now, I don't think we're done, right? Because what else do we need to find? We need to find the nth term. We need to find the formula, A sub n. Okay, A sub n. So that when I plug in 75, I get back 15. And when I plug in 90, I get 45. Here's how I'm going to do this one. I'm going to start with this A sub n equals A sub 1 plus n minus 1 times D. I know D is 2. Use either one of these points. I don't know what the first term is. You could probably count backwards from 15 and go subtract 2 75 times, but I'm not going to do that. Okay, here's what I'm going to do. I'm going to use one of these two terms. I'm going to use the fact that A of 75, the 75th term, is 15. That means my n is 75, and that means that term is a 15. So that becomes 15 equals A sub 1 plus 75 minus 1 times 2. All right, go ahead and figure out what your first term is. So I get 15 equals A sub 1 plus 74 times 2. So what is that, 148? Okay, 148. Subtract 148. And so now I got negative 133 is my first term. I know my D, I know my first term, so now I can do that A sub n formula and just come up with the final general term. Okay, for that. It's got to have a 2n in it, and it will. So I'm going to go back to A sub 1. Hold on here a second. I'm going to go back to A sub n equals the first term plus n minus 1 times d. I'm going to substitute everything in for except for n. So A sub n is negative 133 plus n minus 1 times 2. And what does that end up equaling? negative 133 plus 2n minus 2, and then this will be my final answer. Okay. Plug in 75. You get back 15. Plug in 90. You get back 45. That's just a quick double check. Okay, you gotta be able to do that. So that is that formula for that term. All right, I'll hit that other stuff tomorrow. Take off these last 4. Okay, so that's section 11.1. We got to finish up with that summation, and then section 11.2. Get started on that one.